What does Rolle's theorem says? Let f of x be a function defined on a closed interval a comma b if 1. F of x is continuous. Now you see why we started with continuity. 2. F of x must also be differentiable. And 3. Considering these intervals, f of a must be equal to f of b. So if these 3 conditions are satisfied, then there exists a c that is a member of this interval such that f prime of c now, f prime of c equals 0. Now, take note that the continuity is tested on a closed interval, while the differentiability is tested on an open interval. Please, these 2 things are very important. So you test the continuity on a closed interval and the differentiability on an open interval, and check if f of a and b are equal. So if these 3 conditions are met, then it shows that there exists a number c on the interval that is between a and b. Now, such that f prime of that c is equal to 0. For better understanding of this theorem, let's look at the diagrammatical representation. Y-axis, x-axis. Let's assume that we have a curve like this, whereby this point denotes point A, and this point represents point B. This is the interval that we are considering. This is f of x. Now, what does continuity mean? Continuity means that continuity means that the curve does not have a break. It is not disconnected. There is nothing like discontinuity. Assuming we have something like this, whereby there is a break, then you can say the function is discontinuous. But while representing it like this, there is no contour, there is no break, there is no sharp edge. It is not discontinuous. So discontinuity is met. First condition on this interval now has been satisfied. Then what about differentiability? If it is not differentiable, then it means that there will be a vertex. There will be a vertex, something like this. If you have something like this as a curve, there's something like this whereby this place is positive and this other part is negative, it means it is not differentiable. But looking at this function from this graph, it is differentiable. An open interval, it is differentiable. Then the third aspect is that is f of a the same thing as f of b? If you look at this, although this is not a perfect diagram, but if you look at this, you see that they are on the same value of y, which means that this part is f of a, and also the value is the same with f of b. So we can conclude that our f of a is the same thing as f of b. So this is what Rolle's theorem is talking about. It now says that if this thing is true, these 3 things, if the conditions are met, which have been satisfied, then it means that there exists a c on this interval. There exists a c, maybe somewhere around here, such that the f prime of that value is 0. There exists a c such that the f prime of that c is 0. So now, for a better understanding, let's solve some problems. Now, given this function, we are asked to check if Rolle's theorem is applicable. Can Rolle's theorem be applied? This is the function, and this is the interval. What's the first thing you check? You check if it is continuous and if it is differentiable. Do not forget in the previous calculations under continuity, I said that every polynomial function is continuous and differentiable at every point. So in this case, you agree with me that the function is continuous on this. Also, for that reason, it is differentiable. The function is also differentiable on this open interval. And the third aspect of this that we're going to be testing is that is f of a equals to f of b. Don't forget, this is our a and this is our b. So now to test for this, f of 0 will give us 0 squared minus 0 plus 3, which is the same thing as 3. And f of 4, which is our f of b, give us 4 squared minus 4 into 4 plus 3. And this will also give us 3. So because f of a is equals to f of b, then the third condition has been satisfied as well. So you can now state that for these three conditions to be satisfied, then it implies that there exists a c that the f prime of that c is equal to 0. Now what is the f prime of x? F prime of x is the same thing as 2x minus 4. That is, if you differentiate the original function, this is what you get. So it simply means that 2x minus 4 will be equal to 0 at this point c. Then you say that 2x is equal to 4 and x equals 4 over 2, which is equal to 2. So it means our c is 2. So it means at this point where c equals 2, f prime of x is equal to 0.